Alexander Graham Bell, of what fame? What did he do? He invented the telephone, right? He devised a solution to this. He looked at this situation. He said, "This is not good." He also wanted to have two different wires because he invented the telephone, and the telephone is going to have signals going in and signals going out, right? So he had this exact problem. Okay, his solution was ingenious. He designed this. Let's have a look at it. Okay, now can you see it? What is this? I don't know how close it is. It's a real close-up because I wanted to get a good shot at it, right? This is what we call twisted pair. Twisted pair. You can see why it's called twisted pair, because all the wires are doubled up, they're in pairs, they're matched up with another one, they're none just flying out on their own. And secondly, they're not just sort of running parallel to each other, they are twisted on each other. Okay? Now if you take any of the Ethernet cables that are here in the room, right, the blue ones, and you cut one open, don't do it, okay, this is what you would see. Almost identical, in fact. Okay? So you've got a few pairs in there, they're all twisted. Twisted? What difference does that make? What difference does it make when the two wires are not running just parallel to each other, but, you know, they're sort of like a helix, you know, that kind of thing, in 3D space though? What difference would it make? That's exactly right. When you've got these in a different physical arrangement, right, what you're going to actually do, and this is, Bell was a really smart guy, right? He worked out that it would greatly reduce electromagnetic interference, okay, when they were coiled around each other in this way. That they wouldn't muck around with each other's signals nearly as much. And not just that, but their combined magnetic field, because they're still giving one off, right? Their combined magnetic field would actually help to resist interference coming from outside. It wouldn't completely cancel it, but it would mean that if there was like a mild amount nearby, these wires would sort of protect each other, if that made sense. That's why they're all paired. Okay? Each one is protecting another one. If you added a third one in, it wouldn't quite work, because the magnetic fields interact in a different way. And if you had one that was just on its own, hanging out over here, there would be nothing to protect it. Okay? So twisted pair, there are two main kinds. There's unshielded twisted pair and shielded twisted pair. So you remember I said that when they're twisted together, they would help to ward off a lot of interference, but not all of it. Okay? So what sometimes, and that means they're unshielded, there's nothing else around here except maybe a bit of plastic. What some people have designed is a kind of sheath that goes around each of the pairs, okay, that is either made of an insulator or some other kind of material, which again will try and shield out some of that magnetic interference. Okay? Unshielded, shielded. Now, unshielded twisted pair is the dominant type of cabling in the world, in all communication systems. Okay? All Ethernet cables are basically UTP, unless you get really special, expensive stuff. Okay? It's quite cheap to produce, because what you've got here is not very sophisticated. You've got copper wire, it can be quite thin, and it just is wrapped around itself. And we've got machines that can do that very, very quickly. Okay?